Young's modulus of steel. We are going to see about tensile test on mild steel and determine the Young's modulus and various parameters of the given material.
Why it is called Universal Testing Machine. This machine is having capability of various testing like tensile test, compression test, bend test, and shear test. This is why it is called Universal Testing Machine. It is also known as UTM. Parts of UTM: lower cross head, upper cross head, middle cross head. It is a movable one, lead screw, column. Control switches are on, off, up, down, and emergency stop. Up button is used to move the middle cross head in upward direction. Down button is used to move the middle cross head in downward direction. Base section. Control unit. This unit is used for control switches to actuate the master cylinder. It is used to rotate the lead screw for the movement of middle cross head. Before doing a test, we must follow the safety precaution. Wear shoes, gloves, safety goggles, and always keep shirts tucked in. Remove accessories like rings, bracelets, watches, and ID card. To know the safety procedure before operating the machine, check the electrical supply is off position. Check the load and release valve at close position before starting the operation. To know the usage of control switches and load requirement during operation. After completed the test, switch off the machine and open the release valve. Measure the average diameter of the specimen by micrometer and gauge length using ruler. Estimate the ultimate strength of the specimen approximately. Close both release valve and control valve. Fix the specimen vertically into the jaws of upper cross head by rotating the hand wheel. Move the middle cross head in upward direction and clamp the lower end of the specimen into the V-shaped jaws using hand wheel. Attach the extensometer firmly to the specimen and set to 0. The load range is adjusted to 10 tons. Switch on the motor with the help of push button on the control panel. Now slowly open the control valve to a small opening so that the load was applied on the specimen. Read the extensometer and record the reading on data sheet. Continue loading on the specimen and read the extensometer reading at each increment of loading. The load should be continued till yield is reached. This is indicated by extensometer showing high values of extension and record the load at yield point. At this point, remove the extensometer and continue the loading until fracture. Note and record the maximum load attained and the breaking load. Remove the broken piece from machine and record the type of fracture. Measure final length and final diameter at neck. Calculate the yield point, ultimate tensile strength, percentage of elongation, percentage of reduction in area, modulus of elasticity. Draw stress strain diagram and indicate all the points.
Young's modulus of elasticity is equal to 20,000 Newton per millimeter square.